Hi everyone, welcome to TGIF, another Friday, another episode. World of edge computing is getting interesting with each passing day, and we're seeing more edge device being infused across industry. There's a new design thinking which is called Akri, which stands for a Kubernetes resource interface for edge computing. And by the way, Akri means edge in Greek. This is a must-watch episode if you want to know more about what Akri can do and what is Akri all about. I'm pleased to welcome Srikantan Shankaran, my colleague and senior technical architect at MTC. Srikantan, welcome to TGIF.
Yeah, thanks a lot, Sandeep.
Wonderful. So, Akri, we'll get to it, but what challenge are we solving right now?
Yeah, I think we all know that Kubernetes is the technology of choice to run different workloads on the edge side of the architecture.
Right.
And then, but we also know that in today's world, we have a lot of factories and where they run devices which are probably MCU based or they are arrays and controllers,
Right.
which by themselves cannot host a Kubernetes cluster.
Correct.
But still, we want to sort of encompass them into the fold and then be able to sort of identify them as resources in a Kubernetes cluster.
Right.
And that's how we bring the goodness of edge talking to the cloud, local influencing, how the handshake happens efficiently. So for us to be able to detect and sort of discover those devices and represent them in the Kubernetes cluster,
Right.
thereby sort of having a good control on the edge computing platform is what we are talking of. Akri makes that possible.
Wonderful. So you mentioned leaf node. That means there are multiple devices which needs to communicate with different message protocols as well as connectivity protocols. How do we
Right.
bring it all together in a very meaningful fashion
True.
without manually configuring those devices?
Sure,
right?
exactly.
Awesome.
Yes.
So help us understand what Akri is all about. How does it solve?
Yeah, it's a CNCF Foundation project, okay, and actually it implements a Kubernetes resource interface.
Okay.
So you have a controller which to which you pass a Helm chart which has the configuration required to support the protocols that need to be understood. And Akri comes with a lot of handlers bundled in, and one of them is for the OPC UA, which is widely used in the industrial automation.
Perfect.
And so this controller is associated with an agent. The configuration has information about the protocols and the
Right.
endpoints that are actually running in that particular factory.
Right.
And the agent will detect as and when they are available and up and running. It will actually automatically spawn those pods which represents those agents, and then they are actually seen as resources. So that way all these applications, they can talk to those endpoints, pick up the information and sort of either do some inference locally or push that information to the cloud for subsequent processing.
Got it. Take the device for a second. I'm just going to, let's take this as an example, right? Imagine this is an edge device, right? And right now, it has very less compute. That means I'm going to use that very, very meaningfully. I can't run Kubernetes here.
Right.
Now, let's say the example saying, I want to make this part of my Kubernetes edge cluster. So help me understand what steps should I take to make it happen?
Sure. So you'll actually have a computer which is running the Kubernetes cluster, which has insufficient resources to do
So
that.
let's take that as this mission, yeah?
Right.
Current, yeah.
Yes, and then you'll go ahead and actually publish a Helm chart which says that which bundles whatever Akri offers in terms of the ability to understand the protocol and discover those devices.
Right.
You actually apply the Helm chart on this cluster, and then the agents come up with which it is able to listen for these signals from these devices. So once this starts publishing at the endpoint that it is advertised, that endpoint is actually embedded in the configuration of the controller.
Right.
So the agent knows what endpoint to look for, and then if it is alive, it is able to pick those signals up, and then it's able to talk to that in the protocol that it is built with. As I told you that it already has a handler to actually understand what that protocol is about. So that way the pod that is spawned to actually communicate with it has all the information to connect to it, and then be able to get this the sort of telemetry from it, and then it can do whatever needs to be done with it.
Awesome. Srikanth, this is great. Why don't we switch to a demo right away, and let's understand how this all works in real.
Sure. Okay. So what I have here is I'm using Azure as a platform where I'm sort of mimicking this kind of scenario.
Got it.
So I have an AKS cluster that is already up and running, which is what you see out here. And then at this time, when I say a kubectl get pod, you see that it doesn't contain Akri yet. It just contains a web application which is used in this demo to showcase the fact that this pod that is detected that endpoint is able to publish to an external application, and that application is able to consume that information. So which is why I only have that web application running.
So basically running the configuration right now.
Yeah, it's a blank configuration at this point in time. So I just want to sort of show that when, so now when I say kubectl get pods, You see that you have the agent and controller running, but you still don't have any of those pods which are going to sort of, because there is no client publishing at the endpoint yet. So now let me go to this virtual machine. So this is a virtual machine, the same VNet as the AKS controller in a separate subnet, and it has two applications which are actually publishing on the OPC UA protocol.
That means they are actually mimicking this device right now.
Right, exactly.
Perfect.
Yes.
Perfect.
Okay, so this is one application. It's a Java-based application, which is actually, you see that this is the endpoint at which it is actually publishing information. So this is based on the OPC UA protocol.
Got it.
And there's one more application, which is a .NET application, which is actually also going to, it's actually a temperature sensor, which picks up the temperature at regular points, and then it sort of publishes at a particular endpoint. So let me run this application as well.
Sure.
And very soon you'll see that it will sort of print on this console the endpoint, which is the, you see that I'm highlighting this.
Okay.
So this is the OPC UA endpoint of this particular client.
Got it.
So now let me go back to the Kubernetes cluster.
Okay. So there you're going to publish these endpoints for discovery.
Yes, exactly.
Awesome.
So you see that, so now initially you remember that the Helm chart was blank, I did not give any configuration, but now I'm saying that, hey, I'm applying this particular Helm chart configuration. You see that there are two endpoints to monitor.
Got it.
So this is the .NET based application that I just ran, and that is actually sort of spewing out telemetry pertaining to temperature. And so this actually uniquely identifies that endpoint. This is the variable I'm looking for from that particular sensor.
Got it.
And the other one here, you see that this is the Java based application which is also running. So now let me go ahead and apply this Helm chart.
Okay.
Yeah, and now when I say
get pods.
Okay, so it has actually created this particular daemon set. So very soon you will see those pods which actually are representing those devices. So let me just do this again. Yeah, you see that you have one pod for each of those applications that have been sort of created. Yeah, so that in summary is sort of the culmination.
Brilliant. So Srikanth, just to simplify what you just demonstrated, let's take, you have a camera in your hand.
Right.
That's one of the leaf node. I can't deploy a Kubernetes cluster there, right?
Right.
Imagine this is my edge compute infrastructure where Kubernetes is running.
Right.
So you're saying because Akri is running here,
Yes.
Akri discovers that camera.
Yes.
And the camera, of course, is giving me feed for inferencing. The inferencing model is actually deployed here.
Exactly.
But the fact of the matter is Kubernetes is controlling that particular device so that data transfer happens and it's automatically discovered.
Exactly.
Brilliant. Thank you so much, Srikanth. This is a very meaningful demonstration. So as you saw, Akri solves the problem of making sure that the leaf nodes, the edge devices, which probably is very minimal footprint of compute infrastructure, how do we make them part of a Kubernetes edge cluster? That's what Akri solves. So thank you so much, Srikanth, once again.
Thanks a lot,
your time.
Sandeep.
And with that, thanks for watching us today. Have a wonderful Friday. Keep watching TGIF and have a great weekend ahead. Bye-bye.
Thanks a lot.